Hello class and welcome to lesson review day 2. And today we're taking a look on different methods of counting. The two most popular methods of counting we used were permutations and combinations. Remember, order tells us if order is important or not, is if we're doing combinations or permutations. Okay? All right, so different things to help us out, or different topics that are covered in Unit 3 are tree diagrams. We'll do an example of that later on. Factorial notation, permutations, and permutations when the order is important. And when we take a look at order of importance, they say how many arrangements, or how many different ways can you line people up, okay? And that means, and then there's also formula to deal with when you've got a like quantity, terms that are alike or repeats, so you got to be careful with that. Then we took a look at Pascal's triangle, Venn diagrams, make sure you know how to do them and where the overlap occurs. Combinations is another topic where order is not important. So we're just picking 3 people for a group, as opposed to if I was taking permutations, I need a president, a vice president, and a secretary. So order is not important. Don't forget there's direct and indirect solutions, as well as counting subsets. When subsets could be when you donate, you could donate with no money, with 1 quarter, 2 quarters, 3 quarters, 4 quarters, etc. We'll take a look at that. All right, so let's take a look at example 1 from today's lesson. We have the handsome cab has several choices for prospective customers. Okay, you could have an open or closed carriage. You could have a 1, 2, or 4 horse team, and you could have them dressed up or undressed horses. Okay, let's just show all possibilities in a tree diagram. So remember, when we go to do our tree diagram, we start in the middle. Okay. Okay, and the first choice we will do is the carriage. So either the carriage is going to be open or it's going to be closed. Okay, and then we'll take a look at the number of horses, which will change to a different color. So you could have number of horses be 1, 2, or 4. So 1, 2, or 4. Okay, and then last you could have dressed or undressed. So I'm going to try to change color again. Okay, so I'll go D for dressed and U for undressed. Almost done, almost done. And then don't forget, folks, when you're done your tree diagram, to always tell me the number in your sample solution, and we're going to list them all. Okay, so this is open, we're going to go open 1 dressed, open 1 undressed, open 2 dressed, open 2 undressed, open 4 dressed, open 4 undressed. Then we're going to go to closed. So closed 1 dressed, closed 1 undressed, closed 2 dressed, closed 2 undressed, closed 4 dressed, and closed 4 undressed. And if you count those up, folks, you should have number of sample space equals 12. Okay, if you're not sure how to do that, you can do the multiplicative principle where you take a look at the carriage. So the choices of carriage is 2 times the choices of horses. There's 3 different types of horses, times if they're dressed or undressed. So that's another way of taking a look at it. Okay, awesome. Let's keep moving along here. So we've got 8 CHSS prom goers, 4 boys and 4 girls line up for a photograph. How many lineup arrangements are possible if there are no restrictions? Well, if we've got 8 people lining up, 1, 2, 3, 4, 5, 6, 7, 8. Whoever we pick first, there's 8 choices. And then one person's got to be there, so the next person in line has to be 7, 6, 5, 4, 3, 2, 1. And remember, folks, that these options are all multiplied. And hopefully you recognize that as what? Factorial. So number of lineups equals 8 factorial. Plug that in. It's 40,320. Okay. What if the picture must go male, female, male, male, female, male, female? Okay. Well, we could line the 8 up. 1, 2, 3, 4, 5, 6, 7, 8. And we say we're going to go male, female, male, female, male, female. Oops, sorry, female, male, female. Okay? Okay, so taking a look at that, folks, if they have to go male, female, male, female, well, how many possible males are there? There's 4. So there's 4, and then one of those has to be there, so it's going to be 3, 3, 2, 2, 1, 1. Again, these are all multiplied. So number of lineups, okay, are going to be equal to 4 factorial times 4 factorial, okay, which equals 576 ways. All right. Now, let's take a look. There are 4 couples, and the couples must be together. Okay. Well, if the couples must be together, then I'm only doing 4 of these groupings, right? Okay. All right. And we can pick any couple to go first. So that's any couple can go first, but I'm going to times it by 2 because the female could go first or the male. Then one couple's gone, so there's 3 couples left over here. And then when those 2 couples are gone, there's 2 here and 1 final couple. So just remember that these are the couples. Okay, and the 2 represents boy first or girl first. Boy or girl first, because it doesn't say which one's which. Okay, so what you can take a look at is realize that we've got times 2, how many times? 4 times. Okay, so that's going to be 2 to the 4, and then what do we recognize? Hopefully you recognize this pattern, guys, as 4 factorial. Okay, so it's going to be 4 factorial. So number of ways or lineups equals 4 factorial times 2 to the 4, which is 384 ways. Okay. All right. Cool. All right, let's take a look at one of my favorite examples. Is how many ways are there to travel from point A and point B? And remember, you can only move right or down, which means you can't scoot back up, so you can't go up or left. All right, so taking a look here, from A I'm going to go across. There's one way to get here, there's one way to get here, there's one way to get here, and then I'm going to go down, one way here, one way here, one way here, and one way here. Okay, now to get to here, folks, there's no line here, so there's just one way. Okay, going here, I have 2 ways, which means 2 plus 1 gives me 3 ways here. Okay, following down now here, I've got 2 ways. This is 2 plus 2 is 4. Now I got 4 plus 3 is 7. Okay, moving down, I've got 3 ways here. Moving across, I've got 7 ways here. 7 plus 7 gives me 14 ways here. Okay, moving to the next line, 3 plus 1 is 4. I still only have 4 ways to get here, okay? Which means at the end I got 4 plus 14 is 18 ways here. Last line, 4 plus 1 is 5 ways, and then 5 plus 4 is 9 ways, and adding those up, 9 plus 18 is 27 ways. Okay, so therefore there are, taking a look to get from A to B, there are therefore 27 ways to get from A to B. Okay, all right. Okay. Now, if I ask the question, how many ways to get to the bottom, if I ask that question, just on the side note, number of ways to bottom. Okay, if it's on the bottom, you're just going to add these up. So that would be 1 plus 5 plus 9 plus 27. That would equal 42 ways if I was asking that. Okay? All right. Now let's take a look at example 4. When asked about their prom night activities, a sample from CHSS had the following report. So 12 went on a horse and buggy ride, 14 went out for dinner, 40 went to the after party. 8 went to horse and buggy and went out for dinner, 8 went horse and buggy and went after the party, and 24 went out for dinner and went to the after party, and 6 did all three. So show this information in a Venn diagram. Hopefully my circle, let's see if my circle maker will work nicely. All right, we'll just use that. Perfect. Okay, so we need to have 3 circles because we have 3 different categories. So let's make sure this is horse and buggy ride. Just make sure you get it set up the same. Let's go out for dinner on this one. And then the bottom one will be party, after party. Okay? All right, so let's take a look at doing this. So I wanted to leave it so you could see both of them. So we always start from the bottom, ladies and gentlemen. Okay, so start from the bottom or the most number of overlaps. So 6 did all of them. Okay, so for the next one, when we take a look, that 24 went out for dinner and went to the after party. So that means within this section here, we have to have a total of 24. But you've got to already account for the 6, so you take 24, subtract 6, which gives you 18. Okay? All right. Now it says next that 8 went to the horse and buggy and went to the after dinner party. So horse and buggy and after dinner party was 8. But out of those 8, 6 are already accounted for, so there's 2 left over to do that. Keep moving up. 8 went to the horse and went for horse and buggy and out for dinner. So again, that's this one here. 6 are already accounted for, so there's 2 more. Okay. Now we're moving on to some harder ones here. So 40 went to the after party. So in my after party, which is this big circle, I need a total of 40. Okay, so watch the overlap. So what we need to do is take 18 plus 2 is 20 plus 26, subtract it from 40, and the leftover is 14. Okay, the next one, folks, moving up, was 46 went out for dinner. So in my blue complete circle, we have 46. Again, you subtract the overlaps and you're left with 20. Okay. Then we're going to take a look at the next one. 12 went on a horse and buggy ride. So that's this big black circle that I'm outlining again. And we need a total of 12. Well, we already have 6, 8, 10. So there's 2 left that did that. Okay. All right. So we have 3 activities, 3 circles. We've got all of our overlap. And what do we have to remember? That how many people went to prom? We went, so 90 people went to prom, okay? So how many people did no activities? So don't forget that within your sample space of 90, there's going to be some people that didn't do anything. So you take 90, subtract all the numbers on the Venn diagram. So add all these numbers up and subtract it. So 90, subtract all numbers in Venn D, which means in the Venn diagram. So 90 subtract 64 equals 26. So put down 26 people on the outside, which tells you how many people did nothing. Okay? All right. Because then I could ask that question. Okay? So how many people did no activities? Okay? And that would be the question I'd probably ask. Okay? To make sure you know how to set that up. All right. Example 5. There are a group of 6 friends that are deciding if they want to go on a horse buggy ride. How many ways are there for some of them to go? Okay, well, the word some of them to go means you've got to incorporate counting subsets. Okay, so don't forget this is counting subsets, which means each person could decide to go or not. So number of ways, okay? So each person has a decision, yes or no to go, so that gives you the base of 2, and then the exponent is how many people we're talking about. We're talking about 6 friends, so the exponent is 6, Okay, so 6 people, and each person has a decision to go or not. So plug that in your calculator, and you're going to get 64. Now that's 64 ways if it includes the null case. So includes the null set, and the null set means that nobody goes. Okay, so therefore 64 ways for some of them to go. Okay, or 63 ways if at least someone goes. And that does not include the null set. Okay? Awesome. Let's take a look at the next question. Which I think, oh, here we go. B. Okay. Say exactly 4 of them are going. How many ways are there if Taylor will only go if Nick doesn't go? So maybe these guys are ex-boyfriend, girlfriend type thing, and we've got a problem with that. Okay? So we've got 4 people going. Okay? And in this case, the order does not matter. Okay, but we've got to develop some of these cases. Okay, so let's take a look at the different cases we have. So case 1, what if Taylor goes, therefore Nick doesn't? Okay, all right. So if Taylor goes, there's only one way Taylor goes because she goes. Okay, but if Nick doesn't, that means out of the 4 people, we got to choose 3 more. Okay, because exactly 4 of them are going. Okay, because there's 4 people left over. Okay, because if Taylor goes and Nick doesn't, out of the 6, there's 4 other people to choose from. Okay, so that's case 1. Okay, let's do the opposite. Case 2, sorry, I'm trying to move this up, and there we go. So case 2 is going to be if Nick goes and Taylor doesn't. Okay, so if Nick goes, there's only one way Nick goes, times, and so if Nick goes, that's 1 less person. If Taylor doesn't, we're not including that other person, so it's going to be 4, choose 3, and again, that's going to equal 4. Okay, now there is one other case. Okay, and case 3 is if they both don't go. Okay, if they both don't go, that means there's only 4 people left and all 4 of them have to go, which equals 1. Okay, so we have to add them up. Okay, so therefore we take 4 plus 4 plus 1 equals 9. So therefore 9, oopsie, bad 9. 9 ways for the situation. Okay. Okay. All right. We are done, folks. And again, you go to some of the homework pages that we had listed on the first day review. Hopefully this is a good understanding for you. Please see me if you need any help, and have a great day.